get the second derivative, that is d2 by d square of phi of s. This is the formula. Okay, now what we have to do here, minus 1 square is plus 1. We have to find out the double derivative of this phi of s. Now take outside 2. 2 is a constant. In any step, wherever constants are there, just take outside from each function. Either it is derivative, integration, Laplace, or anything. Okay. Now d by ds of 1 upon double derivative of 1 upon s square plus 4 means just split here this two derivatives into single derivatives, d by ds into d by ds. We have to find out first derivative, and then whatever the answer for the first derivative, we have to again derive that function to get the second derivative. Okay, now here 2 is as it is, for the second derivative as it is. Now we have to find out no constant on this only. The first derivative of this, what is the first derivative? 1 upon s square plus 4. Apply 1 upon x formula here, derivative minus 1 upon x square into the bracket derivative. We have to multiply by chain rule, that is 2s. Okay, this is the answer. This bracket is answer for first derivative only. Okay, this second derivative as it is, we have to find out now second derivative of this term. Before that, just simplify. Minus take outside, 2 gets outside, minus 4 is there, d by ds of s upon s square plus 4 bracket square. Okay, now we have to again derive this term, take a derivative of this term, means you have to find, we have to use u by v rule here. Okay, now let's see, v into derivative of s is 1 minus u into, that is s into, now we have to find out derivative of this bracket square. Okay, how to apply, how to do derivative of bracket square? First apply x raised to n derivative. What is x raised to n derivative? For example, x square derivative, 2 into x raised to 1. Here apply first x square derivative, that is 2 into this bracket raised to 1. Okay, now it is not only x, that's why we have to apply the derivative of bracket into multiplication. This is a chain rule. What is the derivative of bracket? 2s. Okay, this is the derivative of denominator v, whole divided by v square. Already square is there, that's why square means raised to 4. 2 to the 4. Indice raised to indice becomes multiplication of the numbers, indices, that is 4. Now what we have to do, this is our answer. Now to simplify this term, don't simplify the bracket. See, in such examples, wherever the square raised to square is there, we have to, if you observe these terms in the numerator, s square plus 4 terms gets common, and in the denominator also that term is there. That's why you have to first cancel the single bracket from the numerator and denominator. That's why how many brackets are can be cancelled? Only one. So s square plus 4, take common and cancel with this 1 s square plus 4, we get cube here. Okay, now here s square plus 4, 1 s square plus 4 gets cancelled, common, take common, we get 1 s square plus 4 minus this 2 to the 4, s into s square, this we get common and to get cancelled with this 1, we get s square plus 4 bracket cube. Okay, this is very important step, everywhere this is same. Now simplify, 1s square minus 4s square minus 3s square plus 4 as it is. Now take this 4 inside or minus inside and reverse the term. 4 into 3s square minus 4 upon denominator is same. Okay, this is the most simplified answer. You can take 4 inside also, 12s square minus 16. Okay, now next. Laplace transform of, this is multiplication of two terms. One is sin t and one is bracket. That's why we have to first simplify this bracket by taking a sin t inside this bracket. Is equal to Laplace of t square sin t minus 3 into t sin t plus 2 into sin t. Now take Laplace inside and ultimately take constant outside of the Laplace in each step. Laplace of t square sin t minus 3 outside, Laplace of t sin t plus 2 outside, Laplace of sin t. Now we have to find out these three Laplace separately. In these three Laplace, this is only sin t Laplace, which is standard sine Laplace. Here t into, here t square into. We have to use multiply by t property in these two examples. Okay, to find out these two Laplace, we have to use multiply by t property. If you observe these two Laplace here, multiply by t function is same, sin t here. That's why we have to calculate sin t Laplace first. Let f of t is sin t, okay? And then Laplace of f of t is 1 upon s square plus this number square 1. Call it as if I of s because we are going to use the property. Now first multiply by t, 1t property. Laplace of t into sin t becomes, formula is minus 1 raised to 1 d raised to 1 upon ds raised to 1, that is first derivative of phi of s, this sin t Laplace. Minus 1 raised to 1 is minus, d by ds of phi of s is 1 upon s square plus 1. What is derivative of 1 upon s square plus 1? Minus 1 upon s square plus 1 bracket square into derivative of this bracket is 2s. Minus minus gets cancelled, answer is 2s upon s square plus 1 bracket square. This is the answer for this Laplace. Okay, now this Laplace. Laplace of t square sin t is equal to minus 1 square. Here 2 is there, that's why everywhere n replaced by 2 in the formula. Minus 1 square, second derivative of phi of s. What is phi of s? Laplace of sine, that is 1 upon s square plus 1. What is minus 1 square is plus 1. Double derivative split into single derivatives. Take first derivative outside and we have to find out first derivative of this term as it is. That is minus 1 upon x square into 2s as it is. Now take minus 2 constant throughout the bracket, throughout the term outside, minus 2. This derivative as it is, s upon s remains in the numerator upon this bracket square. Okay, again use u by v rule here. Okay, v into, that is s square plus 1 bracket square into s derivative is 1 v, minus u into derivative of this bracket square is 2 into this bracket into this bracket derivative multiply by chain rule, that is 2s whole divided by v square, that is already square is there, square means raised to 4. Now take common from the numerator s square plus 1 bracket and cancel with this 1 bracket in the denominator. What we get here, s square plus 1 bracket minus as it is 2 2 the 4 s into s square, and this term already we get cancel. We cancelled already, divided by 1 s square plus 1 gets cancelled from this denominator, we get cube. Okay, as earlier in the example, this is very important step. Now s square minus 4s square, again minus 3s square plus 1 as it is, take minus inside or 2 inside, it becomes s 6s square minus 2 upon this bracket s square plus 1 bracket cube. Okay, that's why it is the second Laplace. In the original example is, therefore call it as either 1. Therefore from 1 Laplace transform, this is our original example, this is Laplace transform t square sin t is this answer, minus 3 into Laplace transform of t sin t is earlier example, this number, this term as it is, and plus 2 into Laplace of sine is 1 upon s square plus 1. Okay, now again 3 to the 6 and this 2 terms in 2 comes in the numerator. This is the final. Don't simplify this because these are biggest terms. When only 2 terms are there, just try to solve that or simplify that. When more than 2 terms or complicated terms are there, just keep that as it is. Now consider next example, t square. Now we already studied exponential property, right? Now we are now we studied this multiply by t property. In some example, both multiply by t and exponential property comes together. For that, consider the example. Here is the example. Laplace of, we have to find out Laplace of t square e raised to minus t cos t. Here cos t is the original function. Okay, exponential is multiplied to cos t. That means we have to use exponential property here, and again t square is also there. That means we have to again use multiply by t property. But the question arises, which property we have to use first. Okay, now remember, we have to use multiply by t property first and at the last exponential property. Okay, Remember, everywhere whenever exponential comes with other property or other term, exponential property use we are going to use at the last. Okay, that means what is the exponential property? You already studied that property. Okay, this is the property that if exponential into function is there, that is phi of s minus a or s plus a. This is the original exponential property. Okay, depend on this number. If positive number is there, we have to replace it minus a, or negative. If it is negative, then we have to use phi of s plus a. What is phi of s? This function's Laplace, which is attached to exponential. That's why here, if you want to use exponential property at the last, we have to find first Laplace transform of t square cos t. Okay, what is t square cos t Laplace? How to find? Multiply by t property. Just we have studied this. Okay, now let f of t is equal to cos t, the original function. Laplace of f of t is s upon s square plus 1. Call it as phi of s. Okay, multiply by t square property we have to use here. Minus 1, this is 2, that's why minus 1 square. Second derivative of this phi of s, that is s upon s square plus 1. Okay, now again minus 1 square is plus 1. Double derivative split into two derivatives of s upon s square plus 1. Now here we have to use first u by v rule. Okay, v into derivative of s is 1 minus s into derivative of this denominator is 2s whole divided by v square, that is s square plus 1 bracket square. Now simplify. S square plus 1 minus 2s square. Rest of the terms as it is. Denominator also as it is. 1s square minus 2s square minus s square. Okay, plus 1 minus s square upon denominator as it is. Now this is again second derivative. We have to find out by using again u by v rule. Okay, what is u by v rule? V into derivative of numerator. What is the numerator? 1 upon 1 minus s square derivative is 1 derivative is 0 minus as it is s square derivative is 2s. That's why derivative of numerator is minus 2s square here. Okay, v into derivative of u minus 2s square minus 2s minus u into, this is u, into derivative of this v. V derivative is 2 into s square plus 1 into bracket derivative multiply by chain rule, that is 2s. Okay, this is numerator of u by v rule divided by v square. V square is this bracket, already square is there. Its square means raised to 4. Okay, now simplify. This is minus 2s, this bracket as it is, minus this 2 to the 4 s into 1 minus s square. And now again this one bracket is common. Just take common one bracket, cancel with this one. We get here only for one term. Here one term gets common, and here cube, bracket cube. Okay, now simply by this term, minus 2s cube minus 2s minus 4s minus minus plus 4s cube. Okay, now 4s cube minus 2s cube, 2s cube minus 2s minus 4s minus 6s. This is the most simplified answer for this Laplace t square cos t. Okay, now we are going to use exponential property because our original example is not this. It is the part of our example. We have just calculated the Laplace of that term, t square cos t. Now apply exponential property. Before that, write down the exponential property. Now exponential property is Laplace of e raised to minus at f of t is phi of s plus a. Okay, instead of minus here plus. What is phi of s? It's Laplace, means above Laplace. Now here e raised to minus t is there in our example into t square cos t, which is equal to phi of s. Here minus 1 is there, that's why it is plus 1. Okay, where Laplace of t square cos t is this answer. Call it as phi of s. In single example, you can use phi of s multiple times by just self understood term. Okay, you have to just understand this phi is different, this phi is different. This phi s is for this Laplace, and we are going to use the exponential property here. For that we need one phi of s to denote this Laplace. Instead of phi 1 phi 2, we just neglect all these terms, just call it as phi of s. It is self understood term. Now here phi of s, put this value here. Therefore final answer for this is our original example, is equal to phi of s plus 1. What is phi of s plus 1? We have phi of s. Instead of s, we just replace s plus 1 everywhere. Okay, where yes is there, here yes, here is, yes is there. That's why everywhere in three places we just replace yes plus 1. Okay, this is our answer. Now just simplify terms. Now expand this cube. A plus b bracket cube is a cube plus 3a square b plus 3ab square plus b cube minus 6s minus 6. Okay, now multiply these two inside. Okay, minus this term as it is, denominator as it is. Okay, now 2s cube as it is, 6s square as it is, 6s gets cancelled, 2 minus 6 is 4 divided by bracket cube as it is. Okay, this in the denominator just expand this square, a square plus 2ab plus b square is 1 plus 1 becomes 2. Okay, this is our final answer. Now consider one more example like this. Laplace of t square e raised to minus 80 sine hyperbolic 80. Here exponential property is also there and t square property is also there. Before that, exponential property comes at the last. Let f of t is sine hyperbolic 80 first. What is Laplace of f of t? Sine hyperbolic Laplace we know. For fifth number of formula, for sine hyperbolic, a upon s square hyperbolic function, for that minus sign is there in the formula, minus a square, call it as phi of s. Now we have to apply t square here property. What is t square into? First t square into sine hyperbolic 80 minus 1 square double derivative of phi of s, the sine hyperbolic Laplace. Put phi of s as it is, and minus 1 square is plus 1, double derivative split into single derivative. Now we have to just take this a is a constant, take outside and d by ds. Now we have to find out this derivative. 1 upon a square plus minus a square derivative is 1 upon x derivative, apply here, minus 1 upon a square minus a square bracket square. Okay, into the derivative of bracket, that is 2s. This is the first derivative. Okay, this one. Now take minus 2 outside, minus 2a comes outside, derivative of yes, here yes upon this bracket square. Again you have to find out this derivative by using u by v rule. Okay, minus 2a as it is outside, u by v rule. Now v into bracket square into derivative of u is 1 minus u into yes into derivative of this bracket is 2 into a square minus a square into the derivative of bracket is 2s divided by v square.